What we're going to go over next is functional notation. Now, certain equations, just like we've looked at graphs and mapping and tables, certain ones of those can be functions. Equations can also be functions. Once you determine what type of equation, which ones are functions and which ones aren't, they can be written in a certain way called functional notation. Example, this equation right here is a function, and later on we're going to look at equations and tell which ones are functions and which ones aren't. But right now we're going to go over this special way of writing this equation. Remember when we were talking about domain and range? The domain was usually the x. That's an easy way of finding the domain in an equation. You look for the x, that's the domain. The range was usually the y, going up the y-axis. This right here is the range of this equation. To write this equation in functional notation, a letter and parentheses will be used to name the equation. What we're going to do is we're going to use a letter, just one letter, to name this entire equation up here. And it doesn't matter what letter it is. A lot of times they use the same letters. A lot of times they're going to use the letter F because that means it's a function. Sometimes they'll use the letter H. Sometimes they'll use the letter G. But what they're going to do is they're going to use one letter, and that way you can distinguish between the different equations and see which one they want you to use. So the way I rewrite this is I'm going to use a letter and parentheses to name this equation. And this letter and parentheses will take the place of the range in the equation, meaning the only thing that's going to change is this part right here. I'm going to change this part. I'm going to use one letter to name this entire equation. So here's an example. We're going to take this equation right here and we're going to use a letter to name it, like F. So what I'm going to do is I'm going to write F. That's going to be the name of this equation. I'm going to use parentheses. Inside these parentheses, I'm going to put the domain, or the variable that you're using, x, is equal to. This right here is the name of this equation. It takes the spot of the range. The rest of it is written exactly as it is up there. So the name of this equation right here is f, and the way you say this is f of x. As opposed to this one, this is a completely different equation. This one I can't use f because I need to distinguish it as being different than the other ones, even though it still is a function. So I'm going to use a different letter, like G. I'm going to use parentheses. Inside the parentheses, I'm going to put whatever variables over here, x. G of x is equal to x squared minus 9. That way, later on, if they give me something and it says this, it says f of x, that means I'm going to be using this equation. If it says g of x, that means I'm going to be using this equation down here. It's a way of naming the equation. This right here is naming this equation. It's a short way of writing that entire equation, or telling somebody that they need to use this one. F of x is this equation right here. The reason you do this is to evaluate this function. You're going to plug numbers into the equation and get another number out, in a sense generating points. So look at this. This is f of x is equal to x plus 3. What they're going to do is they're going to replace a number right here, like this. So for this equation, I'm going to plug 5 into it like this. Where the x is, I'm going to put parentheses, plus 3, and then inside that parentheses, I'm supposed to put a 5. Once I put that 5 in there, then I follow my order of operations. Order of operations tells me I need to add these together. 5 plus 3 is 8. This number is what you would put in as your answer if they told you to evaluate this function. This time I used the number 5. I could write this: f of 3 is equal to 3 plus 3. 3 plus 3 is 6. That's the answer I would get if I used 3 in that equation. So they're going to tell you which function to use, and then they're going to tell you the number to put in there, and then you need to follow your order of operations to get the number that goes with 3. 3 and 6 go together. 5 and 8 go together. So again, when it's written this way, it's the way you say it is f of x, f of x. And then they will give you problems that look like this. If f of x is equal to 5x minus 3, and g of x is equal to x squared minus 2x, find the following. So let's look at what they want us to find. The first one they want us to find is this. They want us to find f of 5. They want us to take 5 and plug it into this equation right here. The way I'm going to do that is I'm going to rewrite it. Everywhere I see an x, I'm going to put parentheses. And then I'm going to take that 5 and put it inside those parentheses. Once I do that, then I follow my order of operations. According to my order of operations, I'm supposed to multiply first. 5 times 5 is 25. And then I do my adding and subtracting. 25 minus 3 is 22. That's the number you would plug in as your answer for this one, 22. The next one is g of negative 2. I'm not going to use this equation. This g tells me I need to use this one over here. What I'm going to do is I'm going to rewrite this, and everywhere I see an x, I'm going to put parentheses. Parentheses, put an exponent of 2 on the outside of the parentheses, minus 2, put another open parentheses. And inside those parentheses, this is the number I'm supposed to put, negative 2. And then I follow my order of operations. My order of operations tells me I need to do my exponents first. That's negative 2 times negative 2. Negative 2 times negative 2, a negative times a negative is a positive. I did my exponents first. Once I do my exponents, then I can multiply or divide. I've got multiplying over here. This is negative 2 times negative 2. A negative times a negative is a positive again. And then my last step should be adding and subtracting. I'm going to add these two together, get 8. 8 is my answer on this. For this equation, negative 2 and 8 go together. It's important that you rewrite these with parentheses where the variables are. F of negative 3, and I'm going to use this equation right here. So what I'm going to do is I'm going to write f of negative 3, and I'm going to rewrite this equation, and everywhere there's a variable, I'm going to replace it with parentheses. Parentheses, put the exponent on the outside, minus 3, put the parentheses, plus 12. And this right here tells me I need to plug a negative 3 inside those parentheses. Put a negative 3 there, and a negative 3 there. Then it's an order of operations problem. According to my order of operations, and looking at this problem, I need to do my exponents first. That means I take negative 3 times negative 3. A negative times a negative is a positive. 3 times 3 is 9. Rewrite the rest of the problem. After exponents, I need to do multiplying and dividing. There's multiplying right here. So I bring down my 9. Negative 3 times negative 3, positive 9. And bring down my positive 12. Now I need to do my adding and subtracting. 9 plus 9 is 18. 18 plus 12, 30. It's really important that you put these parentheses, use these parentheses in this problem. Here's the reason why. Parentheses are going to be really important for a problem like this. I need to take this equation and I need to plug negative 1 into it and see what I get. So f of negative 1 is equal to negative. Notice there's a negative right there. Then I put the parentheses. I put the exponent on the outside of the parentheses. There's another negative. Minus. I open and close the parentheses. Plus 10. Inside those parentheses, I'm supposed to put this negative 1. A negative 1 goes inside there. A negative 1 goes inside there. I bring down everything except what I'm about to do right here. This negative sign gets brought down. These parentheses are still here. Minus negative 1 plus 10, because the only thing I'm supposed to do here, according to my order of operations, is take negative 1 and square it, and then put it inside there. Negative 1 squared, that's negative 1 times negative 1, it's a positive 1. That's the only thing that changed there. I still need these parentheses to show that I'm multiplying. What am I multiplying? On the outside of this, there's a 1 right there, and there's a 1 right there. That means I'm going to take negative 1 and multiply it to 1. It's important that you bring down this. Negative 1 times 1, negative 1. A negative times a negative is a positive. 1 times 1 is 1. That's positive 1 plus 10. Bring down that plus 10. After I do my multiplying, then I need to do my adding and subtracting. Add these together. 0 plus 10. 10 is my answer on this one. So it's really important that you have these parentheses so you can keep this negative sign on the outside and then multiply it later.